I am going to propose and examine hypothesis using this data. My hypothesis is that houses in London are more expensive than outside. Discuss the data. I have found the data I will be using from a database, and it is therefore secondary rather than primary, as I did not collect it myself. This means that there may be some problems with the reliability of the data. For example, there may be some pieces of data that look like anomalies, that is, pieces or data that are significantly above or below most of the other pieces of data. I will need to decide what to do with these pieces of data appropriately. I will not simply ignore them, but try to work out if they are results of human error or not. To do this, I can use the calculation 1.5 times the IQR above the upper quartile or below the lower quartile, to work out whether the data is an outlier. This is important as anomalies may skew that data. I predict that there may also be data that is missing. If this happens, I will choose other data, but I may be able to use my charts and graphs to investigate and predict an estimate of the missing data would have been according to the rest of the data. Cost is quantitative, as it is numerical, and also usually considered to be continuous, as it can contain infinite values between. This is important as it will affect what chart and graphs I use. The type of housing is qualitative. Discuss the sampling methods. I have been given much data, but I am going to sample just 64 houses for each category. I have chosen this number because of the time constraints. However, I believe that 64 houses is enough to make a reasonable comment about my hypothesis. It is also a good number to use as it is divisible by 4, and therefore will be easy to find the quartiles and the median. I will first need to stratify my data in order to make sure that the data is in proportion. For example, when I am looking at houses inside of London, my strata would be type of house, as I will need to make sure that the number of each of the 3 different types of house in the sample of 64 houses is in proportion. The formula I will use for this is number of houses in group divided by total number of houses times sample size. A possible problem here is that I get a number below 0.5. I will need to consider whether to completely ignore this type of data, or whether to round to 1 incorrectly, so as to make sure that the type of house is represented in the results. I think that I will probably ignore it. Once I know how many houses form each group I need, I will then need to randomly select these houses from the data. For example, if I need to find 15 London semi-detached houses from the 110 London houses, I will then number them between 0-109 and then use run #sign function on my calculator to generate random numbers between 0 and 109, making sure that I ignore the decimal. I will then choose this house from the data and put the information in a separate table. Discuss the graphs you will use for each hypothesis and why. I am now going to talk about the chart and graphs that I will use to prove or disprove each hypothesis. Hypothesis 1. For hypothesis 1, I am going to stratify my data according to house type, and put the data that has been randomly selected into a table that includes both their type and prices. I will need to group the 64 pieces of data. I will need between 6 and 8 groups, depending on the data. I will choose the size of the groups according to my data so that there are 6-8 even groups. I will then put this data into 2 cumulative frequency, one for houses within London and one for houses outside of London. The reasons that I do this is so that I can use the cumulative frequency graphs to make estimates of the mean and quartile, and draw a box plot. It is by comparing these two box plots that I will be able to prove or disprove my hypothesis. They will provide a very visual indication of whether it is right or wrong. As previously mentioned, I will also use the IQR to identify any outliers and exclude these from my box plot, instead marking with a cross outside of the box plot so that they do not affect my conclusion too much. I will also find the mean of the data and consider how that affects my hypothesis. To do this, I have two choices. I can go back to the original 64 pieces of data, or I can find an estimate of the mean from my grouped frequency table. I think that I will go back to the original data, as, although the estimate may take less time, the original data will provide me with a more accurate mean. When discussing this hypothesis, I will compare the highest and lowest values, the lower quartile, the median, the upper quartile, and the mean of the two sets of data. I will also consider the interquartile to see how consistent the data is and the skewness of the data, to think about whether the data lies mainly above or below the middle house, or the median. I predict that,